We're all obsessed with making AI smarter, right? Building bigger and bigger models. But what if the real secret to unlocking its power isn't a bigger brain, but a better team? Today, we're going to dig into this really cool paradox that might just change how we think about building AI.
And that whole paradox really comes down to this one question. I mean, it sounds kind of contradictory, doesn't it? But as you're about to see, the answer is a big yes. And that yes, well, it shines a huge spotlight on a major weakness in how we're building AI right now.
Okay, so let's be real. Today's large language models, the LLMs, are absolutely brilliant. We kind of treat them like this lone genius, right? This one giant, all-knowing brain you can throw anything at. Ask it to write poetry, code some software, heck, even pass the bar exam. And honestly, most of the time they do an amazing job.
But, and this is a huge but, there's a catch. Some new research is showing that when you give this lone genius a problem that's just a little too complex, something that needs real, careful, step-by-step reasoning, its accuracy just collapses. It completely falls off a cliff. It's this thing called accuracy collapse, and it's a massive bottleneck. And the scariest part? Just making the AI bigger doesn't seem to fix it.
And look, these aren't some kind of impossibly hard problems, at least not for us. We're talking about things like the game of 24, where you get 4 numbers and have to make them equal 24, or the Tower of London puzzle, which is a classic planning game. All they really ask you to do is think a few steps ahead and, keep track of what you're doing. But it's exactly that kind of structured thinking that makes these super smart AIs just stumble.
So, okay, if this lone genius idea has this massive fatal flaw, where do we go from here? Well, the researchers behind this study looked for inspiration from the best problem solver on the planet, our own brains.
Yeah, they drew inspiration from this really cool concept from neuroscience called global workspace theory. And the basic idea is pretty simple. Your brain doesn't have one single all-powerful processor doing everything. Nope. Instead, when you're up against a tricky problem, your brain dynamically pulls together a custom coalition of specialized little modules. Think of them as experts, and they all work together on a shared mental whiteboard to figure it out. It's all about teamwork, not a solo act. And that is exactly the idea behind this new system called BIGMAS. It stands for Brain-Inspired Graph Multi-Agent System. And the goal is, you guessed it, to stop relying on that single AI genius and, instead, start building an AI dream team.
And this really shows you the difference side by side. On one hand, you've got the lone genius model, that one single AI trying to do everything at once. But on the other hand, you have the expert team approach, a whole crew of specialized AI agents, where each one tackles a specific piece of the puzzle, and they all collaborate.
So how does this AI dream team actually play? Well, here's the playbook. First, you've got a manager agent, they call it the graph designer, that looks at the problem and assembles the perfect team for that specific job. Then, everybody gets to work on a shared whiteboard, or workspace, so all the agents can see what's going on in real time. And finally, there's a project lead, the orchestrator, who guides the team and decides who does what next. It's super organized.
Now, that all sounds great in theory, right? I mean, it's inspired by the brain itself. But the real question is, does it actually work? Does this collaboration really lead to better results? Let's take a look at the data. And wow, the results are pretty staggering. Take a look at this. On that tricky Tower of London puzzle, a really powerful model, Claude 4.5, scored about 57% accuracy on its own, which, isn't terrible. But get this, when they took that exact same model and just organized it into a team using the BIGMAS framework, its accuracy shot up to 93%. They didn't make the AI smarter, they just made it work smarter, together.
I mean, that's a 36 percentage point increase. This isn't just a tiny little bump, it's a genuine game changer. It proves that the system, how you organize the intelligence, can be just as crucial, if not more so, than the raw intelligence itself.
And it's not just about beating a solo AI. BIGMAS also goes head-to-head with other advanced teamwork methods, like React or Tree of Thoughts. And as you can see, it comes out on top. It seems like its unique brain-inspired architecture, that custom team and shared workspace for every problem, is really the secret sauce.
What's especially cool is how adaptive this whole system is. This heat map basically shows us that the manager agent builds a different team depending on the job. So for a Matthew problem like the game of 24, it calls in the generator and validator agents. But for a planning puzzle like the Tower of London, it brings in the analyzer and optimizer specialists. It's just like a really good manager who knows exactly which experts to assign to a project. So what's the big takeaway here? What does this all mean for the future of AI? Well, it suggests we might need a pretty big shift in how we think. Maybe we should focus less on just building bigger, more powerful models and more on building smarter systems. And the researchers themselves said it best. This isn't about choosing one over the other. They say that multi-agent coordination and model-level scaling are complementary, not competing. In other words, we need both. We need smarter AI models, and we need much smarter ways to make them work together.
Really, the bottom line is this. When it comes to those really tough reasoning problems, a well-organized team can pull off what a lone genius just can't. It turns out that a better system can actually beat brute force intelligence.
And that leaves us with a pretty provocative thought to end on, doesn't it? We're all sitting around waiting for the next massive AI model, for GPT-5 or whatever comes next. But what if the next great breakthrough in AI isn't a bigger model at all, but a better team?